Okay, so picture these massive fields stretching out as far as the eye can see. But instead of growing crops, they're harvesting pure sunlight to power our entire world. That's a solar farm. These are some of the most incredible engineering wonders out there, and they are completely reshaping our energy future. So let's dive into how they actually work, the crazy challenges they face, and the brilliant innovations that are making them smarter every single day. To really wrap your head around the scale we're talking about, just look at this stat. Think about the Three Gorges Dam, a project that took years and years to build. Well, China is now matching that massive output with solar panels every 3 weeks. This isn't some slow, gradual change. It's an absolute explosion in clean energy.
And what's really fascinating is where a lot of these new farms are being built. They're going way up to high-altitude places like the Tibetan Plateau. Why? Well, up there, the air is thin, it's cool, and the sunlight is just way more intense. It lets the panels work at their absolute peak, giving a serious boost to how much power they can generate. But, building these megafarms isn't as simple as just plopping down some panels in a sunny spot. Nope. It's more like a giant, complex puzzle where engineers have to go head-to-head with some of the most powerful forces on the planet.
And that right there is the million-dollar question. Because for all their high-tech design, these solar farms are just sitting out there, totally exposed to the elements. So engineers have to figure out how to make them tough enough to survive, well, pretty much anything nature decides to throw at them.
And the challenges are no joke. We're talking about heavy snow piling up, sometimes over 50 pounds per square foot, enough to crush a panel flat. You've got ice forming, adding all this extra weight and stress. You have insane winds creating powerful turbulence. And then there's hail, which can literally shatter the glass. It is a constant battle.
On top of the weather, there's an even bigger puzzle to solve. I mean, solar farms need a huge amount of land. And this creates a direct conflict, right? Land for energy versus land for agriculture. Two things we absolutely cannot live without. So what do you do? Well, the answer, it turns out, is to get smarter. Instead of just building bigger, engineers are coming up with some truly brilliant ways to solve these problems. So let's check out some of these smarter solar solutions.
So, the first big idea is to stop thinking of the panels as static objects. Instead of just sitting there, what if they could move? What if they could actually follow the sun across the sky, kind of like a sunflower? Well, that's exactly what solar tracking systems do. And there are basically two main kinds. You've got your single-axis trackers, which are the most common. They tilt on one axis, just following the sun's daily trip from east to west. But then you have dual-axis trackers, and they take it to a whole other level. They can move side to side and up and down, pinpointing the sun's exact location, not just during the day, but throughout the entire year. And this chart just shows you how much of a difference that makes. It's incredible. Compared to a boring old fixed panel, a single-axis tracker can boost energy output by about 25%. Pretty good, right? But a dual-axis tracker, it can jack up that number by a staggering 40%. That's a massive, massive efficiency gain from the exact same piece of land. Okay, so we can make panels smarter about finding the sun, but what about keeping them healthy? A single solar farm can have millions of individual solar cells, and all sorts of problems can pop up that are completely invisible if you're just looking at them. We're talking about things like tiny, invisible microcracks in the cells themselves, or moisture that's somehow gotten trapped inside a panel. Maybe some connections are starting to overheat. Any one of these tiny issues can drag down the efficiency, and if you don't catch them, they can lead to much bigger failures down the road. So how in the world do you find a problem you can't even see? The solution is pretty cool. You send in the drones. Thermal imaging drones can fly over hundreds of acres in a single day, and their special cameras can spot temperature differences instantly. They see these hotspots that tell you exactly where the hidden problems are, long before they become a catastrophe. All right, this next part brings us to what might be the most exciting innovation of all. It's a solution that tackles that huge land use problem we talked about earlier. And it's turning solar farms into something much more than just power plants. The idea has a pretty cool name, agrivoltaics. It's all about combining solar power and agriculture on the very same piece of land. So instead of competing for space, they actually start working together, creating this amazing symbiotic relationship. So how does that even work?
Well, it turns out that a lot of crops, especially things like leafy greens or even some root vegetables, don't actually like being blasted by the sun all day. The partial shade from the solar panels protects them, which helps keep the soil moist and can actually lead to better crop yields. It's a win-win.
And this isn't just some small-scale science experiment. These systems are being designed with real modern farming in mind. The panels are mounted way up high, leaving plenty of room for tractors and other farm equipment to just drive and work right underneath them. It seamlessly blends energy production right into how we already grow food.
But it gets even better. This partnership doesn't just stop with crops. This whole approach, which some people call ecovoltaics, can be used to restore entire ecosystems on the land underneath and around the panels.
Take a look at this number. 20 times. What on earth could possibly increase by 20 times on a solar farm? Think about it.
Native bees. It's incredible. Researchers at one solar farm planted a bunch of native pollinator-friendly flowers, and in just 5 years, the total insect population on that site tripled, and the number of native bees shot up 20-fold. They basically turned a power plant into a thriving sanctuary for critical pollinators.
So you've got everything from, and I love this, photovoltaic sheep that graze on the land to keep the vegetation down, all the way to creating these booming pollinator habitats. The whole idea of what a solar farm is, it's just completely changing. It's a total paradigm shift.
And really, that's the big takeaway here. We are watching solar farms evolve right before our eyes, from these static fields of glass and metal into dynamic, living ecosystems that can generate power, grow our food, and support biodiversity, all at the same time.
And it really leaves you with a powerful question to think about. What if the future of energy isn't just about megawatts and grids, but about creating a real, genuine partnership between our technology and the planet itself?